My name is John Peck, and I am a developer and an advocate for Algorithmia. Our mission is, in a nutshell, to take machine learning and make it accessible, discoverable by everyone in the world, and also then to bring it to private companies and act as their AI layer. I'll talk more about that later. If you want slides, bit.ly/AI-API, and you can find me as PECKJON on just about every social channel. So just with a quick show of hands, how many of you right now are developing machine learning models in your company? All right, that's way more than last year. That's awesome. How many of you are using some API endpoint right now which runs a machine learning model behind the scenes, whether it's your own or whether it's somebody else's? Okay. Cool. So we already have some familiarity in the crowd. That's great. I'm still going to take you through kind of just the very basics of what machine learning is and how it works, not any great technical detail. And I'm going to take you through how you can use off-the-shelf machine learning, how you can actually take your own models, deploy them out there into production, and then combine them, and maybe even get some time to show some demos. So in a nutshell, what is machine learning, right? There's tasks that figuring out the exact code to do it is just impossibly hard or would take a very long time. You can't always write a discrete logic path for every single thing you might want to do. And so for those kind of tasks, typically, historically, we've hired humans to do it, right? So that might be recognizing images, reading handwriting, label recognition, et cetera. And we'll do that either with our own team of people or by outsourcing it or even through APIs. Yes, those exist. But machine learning takes that and it sort of identifies a process, identifies a way of doing a thing by this process we call training a machine learning model. And then you can replicate that. You can take that one task and you can get as many copies of it as you want in our wonderful scalable world. And then you can do that at scale without having to be restricted by the personnel base you have. So already there's a lot of machine learning in the world, right? We touch it all the time, everything from Siri when you open your phone and say a command, all the way to those image filters that you're going to see in every single chat app nowadays. Your company may have very specific, very different use cases, but to give you some broad ideas of where this tends to get used. In e-commerce, you've got object detection where you can look at images, you can figure out what's in them, you can make product recommendations based on that. You can segment your customers and figure out how different customers are going to behave, or maybe how to target different ads to different types of customer demographics. Building recommender engines for what kinds of products they might be interested in. Moving more into content, you might be doing keyword extraction or automatic summarization of text that you've got. You might be doing named entity recognition, pulling, say, company names out of SEC documents and that sort of thing and figure out how they relate to each other. Language translation is really obvious. Face detection now in just about everything and being able to recognize individuals. And there's just a whole laundry list of other places that this can get used. Nudity detection to make sure that you're filtering your content properly. Profanity detection for text. Fraud detection for credit card transactions. Sentiment analysis, determining whether your customers are happy or annoyed based on the content of their chat interaction with you. Matching algorithms for things like Lyft and Uber, et cetera. So pretty much machine learning has just a gigantic range of possible uses. A few of my favorite ones, which happen to be hosted on Algorithmia, these are just the ones I'm most familiar with. Parse and McParseface, really great, hilarious name, obviously. But it allows you to take a sentence and break it down into different phrases, parts of speech, figure out how they relate to each other, that sort of thing, so you can start actually understanding the sentences that come in over text. Sentiment analysis, I mentioned, auto-tagging, tweet analysis, so these last two, analyze tweets and summarize URL, those are both kind of combo algorithms where they pull in APIs from other services, like grabbing, the Twitter fire hose, for example, but then also do a lot of other things like sentiment analysis, keyword extraction, et cetera, to give you a whole bundled up result via a single call. More on the image side, colorful image colorization, really cool. You give it a black and white image, and based on the content it sees there, it tries to figure out what the colorized version of that should be. Sometimes it's great, sometimes it's terrible. Every machine learning model is only as good as the data that's been fed into it and how well it's been trained. So a whole lot of variation in results there, but we've already seen some colorized versions of images already used in the journalism world, where papers go out there, they'll pull a historical photo, but to make it feel more relevant, they'll auto-colorize it, and it's believable for their readers. Nudity detection, face recognition, emotion recognition, where you can actually look at an image of a person and determine if they're happy or sad. So again, great for feedback as somebody's experiencing your event or using your application, figuring out if they like what's going on there. And object detection, which just lets you take a picture and identify every single image in it. I'll give you a couple live demos, I think, of some of those at the end. So all of these sound really cool, but how do we actually use them? How do we actually incorporate them into our application? The answer, of course, being APIs, microservices. There's a whole bunch of off-the-shelf stuff out there that's ready to go, and you just have to hook into it. Now, a lot of these come from the big three, Amazon, Microsoft, Google, and they range the gamut. You got to kind of go into each one of those providers and search around and see what there is, But I'll call out specifically, obviously, Amazon Translate and Google Translate, both extremely popular. There's a whole lot of vision services like Amazon Recognition now, which are starting to get a lot of industry use. And what you do is you go in, you search through their index. Each one's going to have a slightly different API, so you're going to read through that code, get familiar with how it is you need to interact with that particular service. Some of them have a multi-step interaction, so it depends on the individual one. Once you've learned that, write your integration code, and you call it ad hoc. And most of these are simply billed by the number of calls that you make. So fairly straightforward in that regard. Algorithmia itself, same thing. We host a whole variety of algorithms. We have actually about 8,000 now, independent machine learning microservices, and these come from developers all over the world, right? So some of them are born out of research papers, some of them are born out of industry, some of them are born out of hobbyist use, and people can come in, they can contribute these machine learning algorithms to our marketplace, and then you can go in and grab and use them. One difference is that we work very hard to actually curate our clients. So you can make raw REST calls if you want to us. We have a standard API for that. But then we also provide off-the-shelf clients in a whole variety of different languages. And our goal here is to basically make that interaction very standard, both across languages and across the different individual algorithms that are implemented by these different individuals. So no matter which one you're calling and no matter what language you're calling from, the syntax is going to be nearly identical. Only the payload itself is going to change in that interaction. So that just makes it easier for our developers to work with that interaction. Same thing, per compute second billing. We don't upcharge for GPUs, and we don't have any kind of subscription plan that you're locked into. It's just each call, you get billed a credit per compute second. That's it. Okay, that's great for off-the-shelf stuff. But for those of you who actually have your own models and want to deploy them out in the wild, how do you do that, right? So just to go back over a very quick idea of how you train a machine learning model, and this won't get you there. You're going to need to go hire a data scientist if you don't have one already. I promise. I've tried. This isn't something you can learn in 24 hours. But nuts and bolts. You get yourself a whole bunch of data, and you label that data. So in this particular case, we have a bunch of different photos of irises, and we've measured the petal height and the sepal height and width, and put that all just into a database. And then for each of those, we've actually had someone go through manually, a human, and say, okay, what species is this particular iris? There's a few different subspecies, right? Setosa, virginica, et cetera. Once I've got all of that data and it's labeled, I take it and I divide it up into a training set and a testing set. Generally speaking, you're talking about 70% of your data to 80% of your data for training, and then the remainder for testing. And the reason you divide that up is if you just train on your entire data set, you get this effect called overfitting, where your machine learning model becomes very good at identifying the particular data in that individual data set. And as soon as you give it another real-world example, it fails miserably, right? So what you do is you use 70% of that for training, and then you reserve that 20% to 30%, and you, after you've trained the model, test on that and see if it's performing well on fresh images that it's never seen before. So you go through, you train that. There's a whole lot of adjusting of different hyperparameters, picking different models that might work in that environment, et cetera. But rinse, repeat. Eventually, you get to a point where you have a trained model, which every time you give it a new image, it can go and it'll recognize it and it'll say, okay, yep, that's Iris virginica. And it gets a certain percentage right. And when that gets to a point where it's acceptable, you take that model and you release it out into the world. Very similar process for text, for recognition of faces, for recognition of sentiment, et cetera. It doesn't really matter what medium you're working in. The idea is you have this curated data set, you go through the training process, you get a model out. All right, so once we've got that, we need to actually take that model and we need to put it somewhere to productionize it, right? Because we can run it on our laptops and that's great, but hey, we have to get it into a server somewhere. So ideally, you're going through, you're maybe even putting these models into Git, retraining them on a regular basis, repushing them as they get better so that you can actually be utilizing them even as you're refining. Those go into some kind of serving or production platform. We'll just drop that onto our web server. Okay, that's a really bad idea. I'll tell you why in a second. We're going to put that on a dedicated server, write some encapsulation code so that aside from the raw prediction, we can have a little bit of logic around it so you can actually have a useful API call that's meaningful to humans and get some result back. And of course, then you call that from whatever you need to call it from, your app, your API client, some service worker somewhere that's going to do batch jobs overnight. Doesn't matter. It's just an API endpoint after that. So why not just run it on the web server, right? So a couple things to know about machine learning, right? There's a variety of different languages. Python is becoming really, really dominant, which is great because that works in really well. A lot of us are already running Python in our web stack. Cool. But C, C++, Java, R is a whole other ball of wax. Once you start getting into those other languages, you start creating, of course, more load on the server. You've got lots more integration to do. In addition, there's a whole bunch of different frameworks. Scikit-learn, NLTK, PyTorch, TensorFlow, et cetera. And if you're just sticking in one, that's fine. But as soon as you start to get multiple different models in different frameworks, it becomes a bit of a problem. And different frameworks are better suited to different types of tasks. So unless you're doing just one thing all the time, you're going to find yourself pretty quickly with 2 or 3 or 4 different frameworks and possibly different languages running for your machine learning. We have worked with companies that have literally thousands of different models in different languages running all the time. And so that has to be very easily able to swap in and out and use just the ones they want at any given time. In addition, you've got processor and memory limitations. Most web servers are a little bit underpowered. And typically, you wouldn't be putting a GPU onto a web server either. So in many cases, when you're doing deep learning algorithms, so things like the image recognition I was mentioning before, a GPU comes in really useful because it's very, very fast at the kind of matrix multiplication that's necessary for machine learning purposes. And so unless you're going to go and build basically what would be your gaming system to be your web server, GPUs don't always make sense in that environment. You might want to keep it separate. And then lastly, you've got your security and your scaling considerations, right? So you don't necessarily want that machine learning model information on the same server in case there's ever a breach. You want to have separate security and access controls over those models. And then you want to be able to scale because your web server might be able to function under very heavy load if it's decently sized. But those machine learning models, they eat up a ton of processor time. So as soon as you start getting a large number of calls, you want to be able to scale that machine learning capability separate from your base infrastructure capabilities. Okay, so you can build your own dedicated machine learning server if you want to. You can do that physically, or you can do that, of course, by, as most of us do, just grabbing a VM out there, grabbing an EC2 instance, for example. Figure out the right balance of CPU, GPU, how much memory you're going to need across your models. And then start building up that stack. It's a little laborious the first time, but after that it's pretty easy to replicate, and then you can just scale from there as needed. Can get a little expensive if you're running heavy GPU machines all the time. Make a microservice around it, right? If you're working in Python, grab Flask, drop your API wrapper around. That makes it, of course, usable from any environment. You do have to then figure out how to meter it, how to secure it, how to actually disseminate it and let people across your organization know it exists, and that's what the rest of this conference is for, talking about all of those other details about APIs. And then figure out how to add scaling on top of that, right? So in many environments, you can just automate that. up to some degree. Often it's sort of hourly billing kind of things, spin up the number of machine instances you need. And that all works well until you have to then repeat it for every different language and every different environment and every different model. And what ends up happening is you get this relatively long lag time between when the machine learning training is done and your data scientists have done their work and come up with something useful, and when you can actually get it into the business cycle. Because it's got to go through your DevOps team, it's got to go through server provisioning, it's got to actually be versioned out onto that, and then they may need to be building new stuff in the meantime. So we've seen 1 week to 1 month lag over that between, hey, we've got something useful you can use, to actually being able to use it in our industry, right? So, the other things you want to think about there, do you want to have a common API across all of your machine learning models? If so, how do you work that into your workflow so that these different teams, as they're deploying their models, if they're building their own servers, writing their own wrappers, how do you standardize across them? And then how do you deal with the auto-scaling and auto-deployment considerations to try and bring that down, bring that time to deploy down? So one thought that might occur is serverless functions, right? Because serverless functions kind of fix a lot of these problems for standard deployment, right? It's a simple setup. You don't have to worry about the DevOps component in most of these managed systems. You're going in, you're just writing code. Great. They come with automatic API wrappers, and those API wrappers are semi-standardized in most cases. Excellent. And they come with automatic scaling. So as soon as you start getting 1,000 hits per second on that API endpoint, the managed service is just provisioning more and more capabilities, and it scales out seamlessly. Wonderful. As well, each of those separate serverless functions is running in its own environment, so you have less to worry about integrating frameworks across multiple code bases. So this is good. It's usually pretty cheap, build per second, free when not in use, all the things we love about this sort of infinitely scalable infrastructure. But when it comes to machine learning, things do tend to fall down a little bit there. Most of these serverless function providers are not really optimized for machine learning. So first of all, you get some language barriers. Python's really popular, which is great. Node is popular, though not many people work in machine learning in Node. Java's pretty popular. If you're looking for R, doesn't exist really in the serverless function world, unfortunately. There is limited dependency support. With some of these, you can jam in your own dependencies by going and creating a custom container and building into it all the libraries you're going to need, and then deploying that out to the service. So it's a little bit of a long round trip, but it's at least possible. With some of them, not so easy, depends what you're working in. And then there's a few dependencies that because you don't actually have access to the bare machine, you just can't shelve them in there. And most importantly, and notable in that category, is anything using GPU. Because these serverless function providers, generally speaking, do not allow you to attach a GPU. So you can't get your CUDA acceleration. You can't be using TensorFlow GPU on those services. And then there's a max execution time now for individual predictions, that 5 to 15-minute range that most of them give. Totally great. If you're doing batch prediction, that's pretty limited. You have to start breaking things up into smaller and smaller segments in order to actually be able to do your batches before the serverless function times out completely. And there is, importantly, no consumer-facing UI. So you might not think of that as a big thing initially, but if you consider the amount of time your company spends disseminating information about each of your individual API endpoints, about what is live when and what models are ready to go, and then communicating across teams. Sometimes it's got to go up a couple layers and then back down a couple layers till it actually gets to the person who wants to consume it, the application developer. So having the person who can see all of those endpoints and all of those functions directly inside the system be completely separated from the people who are going to consume it is kind of a problem inside larger organizations where all of that communication has to take place. So there are, fortunately, machine learning tuned hosting solutions. I'll point out some of the major ones. This is not an exhaustive list by any means. Amazon SageMaker has been really popular lately. And the workflow there is you go in, you train on SageMaker. There's a limited number of languages, but they hit the major ones. You train on SageMaker, you then deploy that out, or you can configure your own container if you're doing some custom work. You can deploy that out to the SageMaker service, make an machine learning endpoint around that, and then write a separate Lambda function or other serverless function to actually call that machine learning endpoint, which is just providing the base prediction, no other logic. And that's going to access that. And then the scaling occurs in those two separately. So as more hits come in, your Lambda functions scale up, your machine learning endpoints scale up. Cool. Google MLE, very similar. You train on MLE, you deploy it as an MLE endpoint. You write separate surrounding logic as, say, a Google App Engine app or a Google Cloud function. Auto-scaling on the endpoints, great. And separate billing for the individual cloud functions or the other stuff you're using to call them. Azure, a little bit different. Train and register the model with a machine learning service. Then you have to define an entry script with all the surrounding logic for it, and an interface config or a deployment config, and a deployment config for the machine that's going to be spun up to execute against them. That goes into their container service or their Kubernetes service. And then the scaling and costs vary by exactly what machine type you're using to actually scale up as you call it. And then on Algorithmia, what you do, we don't focus on the training side at all. You train wherever you like. Might be SageMaker, might be Google, might be on your own machine. You just copy the model file over to us. You create a single serverless function, which loads the model file, does all the predictions just as you would with your local code. So you're copying your own local code over, and then if you want to add extra logic into that, you can. And then that exists as a single serverless function to do the whole thing. And that scales, as you call it, per second billing. GPUs come free, that kind of good stuff. You may have noticed that there's fewer bullet points on Algorithmia than the others. So not to toot our own horn too much, but I've managed model deploys in less than 5 minutes on Algorithmia. In fact, less than 2 minutes for frameworks that I'm more familiar with because it is so straightforward. So just to give you an idea of what that looks like, this is our workflow. You go in, you create a new algorithm, you give it a name. It exists under your own namespace, so there's no collisions. You can give it some descriptive text. You pick the language you're going to be working in, and we support these and are adding more every day. And I think we're the only one that does scalable R as well. Pick whether it's going to have GPUs. Pick whether you want it to be open source or closed source. Hit deploy. Toss your code, cut and paste from your local code into a web IDE, or each one gets a Git repo. So if you want, you can also pull the Git repo and then push it back, and it'll be committed into our service. And then in terms of dependencies, you don't have to do the building and integration locally on your own machine. We figure, pip exists for a reason. All the other dependency managers exist for a reason, right? So you just open up a window, you tell us what dependencies you want, at what version levels you want. When you hit publish on that function, it's going to pull them down, it's going to compile them into your container, it's going to deploy that whole thing out as one piece. And then lastly, you just pick public, private, whether you want it to be accessible from other people. We have a concept of royalties for people that choose to put them in the public marketplace, because then data scientists can get paid back for their work. So actually encouraging the sharing and use of models by everybody. And of course, semantic versioning and all the old versions are callable at any time. And then if you do need to host in private cloud, and this is something you'll want to think about, right? So if you're working within the cloud provider that you prefer for your machine learning, you can keep it all within your same private cloud. So if you run AWS primarily and you want to use SageMaker for your machine model hosting, great. You can have that in your private cloud. No data is going to be exfiltrated, that kind of stuff. If you're going on-prem, I don't think that works yet. I haven't been able to get a hard answer just yet on whether AWS Outpost, for example, supports SageMaker, but so far it's not looking great there, but I will go and research that more later. Algorithmia, what we do is we'll stand up on any cloud or on-prem. So you can take our system, just as shown here, you can bring it into your own private cloud so only your own company uses it, or you can bring it into your own air-gapped environment even, and then nothing leaves your walls. So we've seen that become an increasing trend in the industry, that a lot of the IP that goes into generating these machine learning models is very, very valuable data. And even though by accessing the machine learning model, you're not directly accessing the data it was trained on, you can learn a lot of information about what a company is doing, about what kind of data they actually have access to by hitting those endpoints and getting predictions. So it's super important to some companies that they even have air-gapped installs, and there's just no way for data to get outside the environment. In addition, hybrid cloud is becoming pretty popular. So you may find that you want to store your data in one place, you've already got an existing data lake. You want to run your machine learning predictions on another because it's just more efficient or more cost effective, or you happen to prefer the way that that particular provider works. And then you do have to worry about exactly how to connect those, but most of the time it's pretty well possible. And then one other thing you want to think about is that as you create these models, right, you're going to create them for individual prediction purposes and they're going to be trained up. But one of the really big powers of machine learning in general is the ability to sort of pipeline these together and use multiple models in a larger context. So I just wanted to give you one example of that before we go today. So this is just a little toy that I put together. But nuts and bolts, you give it an image. And it's going to run it through object detection COCO, which is an algorithm for just figuring out what all the objects are in the image and giving you kind of a bounding box on each one. So it would look at this and say, hey, there's a cat primarily in the photo, and then there's a tie right here. And I would get back out the keywords and the positions of those. I take that and I send it over to another existing machine learning model, and this one's a combo. This one is called Analyze Tweets, and I mentioned it a little bit before. It goes out to Twitter, it searches by keyword, gets back a list of tweets, and then it runs it through a few different things. One of them is sentiment analysis, and then ranking them by how strong the emotion is in that actual Twitter statement. And there's some other NLP that goes into that. And then I take that and I send that over to another algorithm in our system. This one's actually not machine learning per se. It's just a wrapper so that I can keep it all in the same environment, which goes out, it hits Cloudinary, which is fundamentally a CDN, which also allows you to do things like quick text overlays and that kind of stuff, and then it hosts the different versions of those images and what. So it takes that original image you gave it, it takes the text it got from Twitter about the highest emotionally ranking tweet containing those keywords, it overlays it, and then it provides it out in the CDN in a bunch of different sizes. And so you go from having this image at the beginning to having this text overlay, and this is what the entire code for that whole pipeline looks like, right? I get in an image, I call object detection COCO and send it the image, and I get back the labels for the objects in it, so I'll get back from that cat and tie. Next line, I call Analyze Tweets, and I send it those tags, and I get back the list of tweets with all of their ranking and all of their other information, keywords and sentiment. I then send that out to Cloudinary, send it the text of the top ranking tweet and the image URL, ask it to do a text overlay, and get back the URL of that image. So 4 lines, really fast to write, just taking advantage of stuff that's already in the system. So once you build up your library of machine learning algorithms, it's sort of a force multiplier, right? And then, of course, I'll just take that and wrap it up itself as another serverless function. And so it can be a single API call from any client to just go and do this. So you can actually, if you want to, try this out. If you search algorithmia.com for meme generator, you can hand it any image, and it'll actually take a minute to process and then fire it back at you. And it looks like I have about a minute left. So I'm going to take that time to actually show you just a couple of real-world examples. And I think I have to just get out of this, just for fun. All right, so colorizing black and white images, as I mentioned. You pretty much give it any black and white image you want. You can upload one, or you can pick from these samples. It runs it out there, it colorizes it, and it gives back the best guess. So this is an actual photo this machine learning algorithm has never seen. And it does a pretty good job. The mountains maybe could be a little bit more color differentiated. And there's a little bit of blur at the top where it can't quite figure out where the skyline is. But not too bad, I think. In the world of combo algorithms, so one of the cool things about videos is they're just a bunch of images, right? And once you have massive parallelism, you can do to an entire video the same thing you just did to a single image. So You hand it a black and white video. You say colorize it. And what it does is it splits that video into separate images. It runs them all through the colorization algorithm. It recombines the images into a video stream, and you get that. It's a little intra-frame blending that's not happening there, but you could add that on top after. Or run it through something different, like, say, a stylization algorithm, right? Same process. That stylization algorithm already exists to sort of Van Goghify a given image, but same thing with the video. You split it up, run those all through, and pipe them back together, and you get a result like this. Or, in the image detection world, you might give a model that can look at an image and tell, say, what cars are in it. I'll run this through that same sort of pipeline of identifying cars in here, and now I can go and I can say, hey, all right, at this point in time, there's a Hyundai hatchback Veloster in the frame. So this is the power of then having a big machine learning library, being able to tack these all together very quickly. I'm out of time, so I will wrap there and just say thanks. If you want to check us out, I absolutely invite you to. If you head to Algorithmia and you use sign-up code AI-API, that'll put a bunch of credits in your account, and then you can just play around with it. And quick side note, we are hiring. We're looking for machine learning engineers. We're looking for DevOps people. We're looking for folks across the spectrum, really. So algorithmia.com/jobs, and talk to me after. I'd love to work with you. Thanks very much.